Okay, so what are the exercises that I would like you to propose to do about clustering? Okay, so it's to perform. We are going to use the CAM-RBAN data because I think that is easier. Of course, you can use the dissect too if you want to. No, because at the end, the only thing that you need to have is a matrix of expression. Then you can play with this matrix as you want. So you are going to perform this hierarchical clustering or the Cummings clustering. So the thing that you need is to have this gene expression table from the exercise 12.1.4. Okay. Basically, that will be your source. So for the hierarchical clustering, the first thing is you need to prepare this table. So you need to have, so this table contains everything, and we want to perform the clustering only in the differential expressed genes. So the thing that we are going to do is we are going to select from this big table that we have with everything, first, the values that p-values under 0.05, and then we will add the row names, the ID. That is important to have the row names, the ID of the genes, and then we will select only the expression. No, as you can see here. Here I don't have the, so here instead numbers you should have gene IDs, but then the rest should be the same with a matrix of expressions. So once you do that is when you can start to do the exercise. So first you need to calculate the distances. So you are going to run the distance option on the gene on this table, and you will get, I mean, we will use the Euclidean distance by default. Of course, if you want to outline other distances, you are free to do it, okay? But as I said, we will use this Euclidean distance by default, so that will be the first part. Second, we will perform the clustering. So it's as simple as run this hclust on the distance matrix that you have, and then select the method. So we are going to use word, because as I mentioned before, is the most common one used for RNA-seq. And then you will plot the hierarchical clustering with this plot. We will put a line, and then we will do a cutoff to select 6 clusters. So this will be an example of how the hierarchical clustering will look like. And also, so we are going to select 6 clusters. We are going to retrieve the number of genes per clusters, and then we will select 3 clusters, and we will retrieve the number of genes again for these 3 clusters. How many genes do we have per cluster? So that will be the second part, and the third will be to visualize the clusters. So to visualize the clusters, it's a kind of a little bit complicated, but you have all the code here. So we are going to use this tidyverse, being able to transform the matrices that we have. So you are going to transform this gene cluster in the thing that is called a table. That is kind of a special object in R. So this is the command to transform that. So you have this Doppler package. And then you are going to get the expression data from the G table, the means. And again, you are going to do the same kind of things because we need to have a special. Yeah, sorry. I will do it as soon as I finish. Well, no, I will do now. I don't need to wait until I finish. Apologies, I forget to upload this one. So this is clustering practice. Okay, I just put in the chat, and then I will upload on the files. So yeah, I was saying that then you need to retrieve the expression data in a special format. Okay, so this is all the commands that you need. And once you have that, you need to join expression and cluster in these tables in this object. Once we do that, we will plot the cluster just using ggplot. So this is an example of how we can do this, and this is how it will look like. Okay, so basically we will have the 3 clusters. You can do this with 3 or with 5 if you want. Well, no, with 3 or with 5, and then you will see the red line tells you the average, and then the rest is the change. So as you can see, I will say the gene one, the cluster one, that is the one that contains more genes, basically is a false positive clusters. This one too, and then here you have something that it may be interpreted, may not, by something like that. No, you still even have one gene, like this one. Okay, that you remember that we were running p-values, adjusted p-values with this sec. We have 3, so probably you are one of those. Okay, so this one is one of them. Remember that we cannot do any interpretation of the data because we already saw that the data was wrong. So that is for hierarchical clustering. We also want to do some k-means. So again, we will the preparation will be the same, so we can even use the same one than before. And then we will run different k-means. So sorry, k-means. So first run this with a k-mean of 3, so you can check how they look like and then get the number of genes per cluster. And then if you want, we can run from k from 2 to 10 and then just retrieve them and store them in this list. And once we have the list, we can, if you want, you can use this FPC just to compare one list with another. It still doesn't have much sense here, as I said. It's just I want to give you the skills. Okay, so that is for the exercise. Question that you may have about this exercise?
Well, I don't know if I am mistaking something, but I don't remember there was a DGE table, just a GE table. Am I wrong?
Yeah, no, you are right. You don't have the DGE table. You create the DGE table during the exercise. So you have the
Oh, sorry. Okay, but the initial one you need to extrapolate your data is the GE table, right?
Yeah, you have the G table from the previous exercise.
Sorry.
Yeah. Any other question? Okay, so you don't have any other question. I will leave you with the exercise. Meanwhile, I'm publishing the next presentation until 4:30. Okay, so according to the plan, let me see. So the thing that probably we are going to do is we will have from 4:30. Yeah, so we will fix the exercise or resolve the exercise from 4:30 to 5. Then I will read you from 5 to 5:30 about gene ontology terms, maybe a little bit more. I'm not sure if it's worth it to do gene ontology analysis with the data that we already have, but I will give you some insights, maybe to do just one simple and quick exercise, even if we don't have meaningful results. And then, yeah, I will talk a little bit about visualization, because at the end you have been using heat maps, so it's not of a much of a difference of the thing that we have been doing until now. Okay, so as I said, we have until 4:30. I will ask at 4:30, how are you doing? Okay. So let me stop the recording.